Like when the metal iron is extracted, the percentage of carbon maybe is more or less. It is adjusted in the cupola furnace where carbon quantity is optimized or maintained. So if it is deficient, you add certain components which will increase the carbon content, or you can decrease in the cupola furnace the carbon present in the steel, the wrought iron and the pig iron they call. So if you are having and rust formation iron oxide on the surface of iron, the steel that you get, uh, it will be porous, and due to the porosity, like from here if the pores, because pores will be something like a tube starting here, moving like to the metal surface, like if this is the oxide layer. So oxygen will diffuse here and the corrosion will continue at the this is metal and this is oxide and this is air. So it will continue at this interface and you will find that corrosion goes on. Whereas if you add small quantity of chromium to this particular steel when it is in molten condition, it will form an alloy. Now an alloy of iron, carbon and uh, chromium percentage greater than 11%, then it leads to formation of a very stable non-porous film on the surface of iron. And this film will protect or will not allow the oxygen to take part in further reaction, and the uh, corrosion will stop. So such kind of film will allow further corrosion to take place, whereas a film formed can stop the corrosion, and such a film is termed as passive film. So, on the iron chromium alloy, you will find that the film formed is very stable, coherent, and non porous. So, it is termed as a passive film. So, a passive film will be forming here. Then, types of chemical corrosion. Now, there are like the first one we saw was due to like the number one was due to O2. Okay. So the second one you see that if you are having certain halogens, now halogen over silver leads to formation of AgCl, which is very coherent, non-porous, and hence protective in nature. But uh, halogen, same halogen like chlorine, on tin, it leads to formation of SnCl4. Now, this SnCl4 is a volatile compound and hence it is not leading to protection at all. So, halogen, like silver, if it is attacked by halogen, it leads to a product which is stable and protective in nature. But when tin is attacked by halogen, it leads to formation of a product which is volatile in nature, and therefore it is no more protective in nature. So it depends on the product of corrosion whether further corrosion will continue or not. Like if you are having Fe and like H2S comes in contact with it, it will lead to formation of FeS, which is porous in nature, and hence corrosion of iron will continue. It will not be protective. Okay. Then liquid metal corrosion. High temperature liquid or molten metal pass through metallic pipes. So when such high temperature molten metals are passing through metallic pipes, see if you are having a pipe like this, now liquid flows over it, but the place where it will drop like this, here at this point, the metal will undergo corrosion due to molten, because here it will be having greater friction or greater stresses are seen at this point. So this point will go on corroding. Then corrosion occurs due to internal penetration dissolution. Example, nuclear reaction. sodium metal used as coolant leads to corrosion of cadmium. So in nuclear reactors, if sodium metal is used as coolant, this coolant leads to the corrosion of cadmium compounds or the cadmium parts. And the next is wet theory of corrosion. As I told you, I think I have discussed this also. That presence of an electrolyte is must in the wet theory of corrosion, and it will take place due to formation of three things. The first reason is uneven surface, that is presence of crest and draft on the surface of metal. Like this is the surface of metal, then this part is exposed to greater concentration of oxygen and this is to the lesser part. So this part is somewhat stressed out and this becomes anodic. Okay, so crest and tuft leads to formation of anodic and cathodic areas, and once the anodic cathodic areas are formed, it will undergo corrosion. Secondly, if on the metal piece, like if the metal is Fe, you are having some metal like passive metal like platinum or any metal which is placed lower in the galvanic series in your electrochemical series below the iron. So a metal which is having higher reduction potential, higher positive reduction potential, now this part starts behaving cathodic and this anode or this part becomes anodic. Now a large anodic area suffers lesser corrosion than a small anodic area. Okay. Now you consider that you are having iron metal only and part of this metal is covered with a cement drop or paint. Okay, now what happens if somewhere cement is there and rest is all iron, then the iron which is here from here to here is in contact with less quantity of O2 and this part is present in large quantity of O2. Now, because of difference in the oxygen concentration along this metal, which is same, and that occurs due to the paint or cement drop or cement getting pasted over it during construction and all, you will find that there leads to formation of an O2 concentration cell. Okay, so there there can be formation of anodic and cathodic area due to presence of uneven surface and that is generally there, so cathode and anode. Then if two dissimilar metals maybe as an impurity, now as an impurity maybe platinum is there, or as an impurity you may be having zinc or magnesium in iron. So both the cases you will find that anodic and cathodic areas are developing. Now what is seen, if the metal which is a impurity is more noble or passive, it will start behaving cathodic and iron will behave anodic. If the metal is more active like zinc and magnesium, then you will see that this part starts behaving anodic and this iron then starts behaving cathodic because the position of these metals in the electrochemical series will decide further corrosion of that particular area. Then the third reason is, so this is termed as um, differential metal cell. Okay, differential metal cell, and this is oxygen concentration cell or differential aeration cell, that is the third part. Okay, so that is how corrosion or wet theory says that presence of electrolyte. Now important part is what are the reaction. Now the reaction is when you are having iron metal at the cathode, it is always at the anode area, like if this is covered with a cement drop, it will be Fe going from the lattice into the solution as Fe2 plus, and two electrons which are formed remains in the metal itself. Now these electrons will run to the cathodic area. This is say cathodic area. So it will run to the cathodic area and the electrolyte is there here. So at this place, these two electrons plus H2O electrolyte will contain H2O. So that will be H2O plus half O2. This is a common reaction, a very general reaction, formation of twice OH minus. So this is the anodic reaction and this is the cathodic reaction, a general reaction. Okay, so we see that under such condition, what is happening is this Fe will come from this side from the anode, and this OH twice will come from this side of the cathode, and it will lead to formation of OH, FeOH twice. Okay, and that is the rust formation taking place. Now, coming to this, the galvanic corrosion, it says that your anode and cathode, now here it is shown like this, but when actually you will see no place you will have something like a metallic wire connecting these two things and like this. This is an experimental setup. A laboratory you can find such setup. In nature you will find such type of, or in during operation or in the machinery you will find such type of uh, a cell formation, like the whole thing assembly is there itself, but the cell is forming. So here what we see, here are the aluminum alloy plates are there. Okay, these are the aluminum alloy plates, and the corrosive product is deposited here, and this is the stainless steel fastener or the bolt, and galvanic corrosion takes place due to aluminum alloy plates, means it will be forming Al2O3, a very protective film on the surface of this. So this, although is placed low, higher in the electrochemical series, but due to formation of Al2O3, we see that iron undergoes corrosion and rust formation and deposition takes place here. Okay, so two dissimilar metals come in contact with each other in presence of common electrolyte, then a cell is set up. Now, once the cell is set up with anodic and cathodic areas, we know it is the anode where corrosion will take place. Okay, so the driving force is much greater than the potential difference between the metals. If the potential difference is large, the driving force is large. If the potential difference is less, then the driving force is less. Then these are some pictures for showing you how corrosion takes place um, in the factories and uh, various applications. Example is copper plumbing connected to steel pipe. Okay, lead antimony around copper wire are seen, but I don't see any copper wire here. Okay, galvanized steel, steel coated with zinc. Zinc is sacrificed to protect steel, and then tin food containers, steel coated with tin. Tin is sacrificed to protect the steel. Okay, so these are some of the examples of sacrificial protection of the lower metal, which is used for preparing the articles or your equipments. Now you can see this is the surface of metal. Now this surface of metal, due to some reason, now what reason? Either there is a crest and the trough, or due to presence of uneven concentration of oxygen in the outside. Okay, so a localized anodic area is formed. This part which is beneath the thing will start acting as anode, and from this part the Fe2 plus will be going into the electrolyte, and rest of the part which is open starts behaving like a cathode, and that is a local cathode, localized cathode. Now at the cathode, just now I told you O2 plus twice H2O plus 4 plus 2 electrons or 4 electrons gives you OH minus. Now from where you are getting these 4 electrons are obtained from the metal itself to the cathodic part, and the electrolyte solution will conduct the ions, and this 4 OH minus and twice Fe2 plus will combine to form rust, which is here, and further it will react with O2, forming finally this particular compound. First it will form FeOH twice, and then it will combine with further half O2, forming Fe2O3 thrice H2O. Okay, so this is a general reaction. Presence of according to the wet theory of corrosion, presence of electrolyte is must for corrosion to take place. Okay, give an outline of yeah. So we come to O2 concentration cell or differential aeration cell. Now, here some certain thing which is there in the theory part is the PPT is not prepared for that. You can read this part from the book. Now, what is seen if you are having acidic medium, because the slides are not prepared, the reactions are not written. I'll just discuss this. If there is acidic medium, then we see that liberation of hydrogen takes place at the anode, at the cathode. So the cathode reaction will be liberation of hydrogen. And where alkaline medium is there, then reduction of O2 takes place and leads to formation of rust. So there are two type of mechanism. One is hydrogen liberation type of mechanism, and the other one is reduction of oxygen type of mechanism, where you don't get hydrogen liberation because the solution is alkaline in nature. Okay, so this you can read from book. Now, coming to O2 concentration cell or differential aeration cell. Now, when you say differential aeration cell, now we see this is a pipeline running over the soil. In some part, it will be going under the soil or under some construction bridge and so many things. So, in short, we find that the metal part is in contact with different concentration of oxygen. Somewhere it is uh, under the soil, or somewhere it is uh, in the atmosphere. Or you consider a metal plate which is dipped inside, uh, which is placed like this, okay, inclined in a water tank. Now half of the metal is in contact with water. Now this water is containing around 8 ppm of dissolved oxygen. This we very well know. Okay, DO we have determined dissolved oxygen, and here the oxygen percentage is very high. What is the weight percentage of oxygen in air by weight and by volume? By volume, how much is the oxygen percentage in air?
1%.
Yes. If you measure 1 meter cube of air, what is the percentage of oxygen in it and what is the percentage of nitrogen in it? Anyone knowing?
21 oxygen and 78 nitrogen.
Okay, so it is almost 21% is oxygen by volume and 78 point something, because rest will be trace gases like carbon dioxide, water vapor, your inert gas like very small quantity of argon and all. Okay. So what we see the this is, and by weight it is 23%. Okay, if you weigh 1 kilogram air, then 23% oxygen and 77 percentage nitrogen is mentioned. Okay, so this is a very high quantity of oxygen. Now, what happens? The place where oxygen is high, it leads to formation of a protective oxide film over it, and the place where it is in contact with less quantity of oxygen, this part behaves like an anode. Now, since this is the place at the waterline, this is the place where the behavior is changing. We see that this part, from this part, like if this is the, then it will take, the corrosion will take place exactly at the waterline. Okay, so this is the part. If the metal piece is going like this, just below the water line, iron will go into the solution as Fe2 plus, and the electrons will be mopped up just above it. Why? Because that is the adjacent part, and therefore it will go on increasing here. The rust formation. Now, rust is not very adherent and will not stick. So, the rust which is forming on this cathodic part, which is in contact with more quantity of oxygen, that goes and deposits at the bottom because it is loose. It is not adherent to the surface of water, surface of metal. So this part of metal is now having, this is all lost, and what all is depositing at the surface of this thing. So you will find that the corrosion takes place just at the water line, okay, because of formation of differential aeration cell or oxygen concentration cell. Similarly, if you think that there is a water tank and a ship is submerged under it, if the ship is submerged under it, or a pipeline is running through the water tank, or through some lake or something like that, and now there is growth of certain blue green algae over here. Okay, so the whole pipeline is exposed to 8 milligrams per liter of oxygen. So corrosion takes place due to a blue-green algae is residing over it. So it has its own metabolism, its own enzyme secretion and excretion. So certain products are there. Apart from that, this organism which is living here will either use O2 or will not use O2, whether it is aerobic or anaerobic. So depending on that, we find that if algae is growing here, it will deplete the oxygen present in water in this region. Now, the moment it depletes the oxygen present around it, say it's a tank and the water is stagnant, then this part will start behaving as an anode, and rest of the part which is in contact with 8 milligrams per liter of dissolved oxygen, that will start behaving as cathode. The moment anodic cathodic areas are formed, dissolution of Fe will take place here and formation of rust will take place at the adjacent area. Okay. Then chemical corrosion versus electrochemical corrosion. So chemical corrosion is happens in dry condition. It is a direct chemical attack. It follows absorption mechanism, and then corrosion product accumulate in the same spot. It is a slow process and it is uniform corrosion throughout the surface. But it is seen that electrochemical corrosion occurs in presence of conducting medium, electrolyte is masked, then involves formation of an galvanic cell with anode and cathode areas, follows mechanism of electrochemical reactions, all reaction anode leading to liberation of electrons which are passed on to the cathode region, and the electrons formed at the anode run to the cathode, and there they are used up, okay, at the cathode surface. Then corrosion product accumulate at the cathode. Rapid process, it's, this one is slow process, this one is rapid process, depends on size of anodic part of metal. Smaller the anodic area, intense corrosion will go on taking place, such kind of pit will go on forming. Okay. So factors affecting corrosion are purity of metal, position of metal in the galvanic series. I think this I have already discussed. Then nature of metal oxide film formed. Yeah, Pilling-Bedworth rule we have discussed. Nature of product of corrosion. If the product of corrosion is very adherent and non-porous, then it will protect the metal underneath, which is below this particular oxide film form layer. Otherwise, it will go on corroding. Relative areas of anode and cathode. A large cathode area and a very small anode area will lead to corrosion reaction, just like very intense localized corrosion, and it is termed as pitting corrosion. So this will the danger is more if the area of anode is small and cathode is large compared to a metal with a large anodic area and very small cathodic area, because a small cathodic area, the reaction that take place at the cathode is the electrons which are formed here at the anode will be consumed. Now this is because of very small area of cathode. We find that these electrons, the rate at which they are consumed is slow, therefore the dissolution of metal becomes slow. Okay, so less corrosion takes place here and more corrosion takes place in such a condition. Things are clear? Then temperature and humidity. Yes, of course, if humidity increases, corrosion increases. Temperature increases, rate of reaction increases. Then presence of corrosive gas will definitely add to corrosion. Highly acidic and highly alkaline solutions will lead to very high corrosion. Okay. Then we come to Porbix diagram. Now the iron system was studied very rigorously and it was found that if you keep the iron part or iron equipment at different pH values, here are the pH values, then you get a Porbix diagram like this. This should not be 14, this should be somewhere around 12 or 14. Okay. So this Porbix diagram is like if the metal as iron metal is studied, then it showed such kind of behavior. Now why such kind of behavior? This is the part of um, passivation by anodic protection. Okay, this is the part of cathodic protection. Now what is meant by cathodic protection? You are having a iron pipeline, and iron, if it comes in contact with noble metals also, it may undergo oxidation. Now if you render this as a cathode, okay, by connecting a negative terminal of battery, so you are making your pipeline behave like a cathode, and that is rendering your pipeline as a cathode. So that is termed as cathodic protection. So this part of the graph is the cathodic protection part. This is the anodic protection part, and this is the part of corrosion. These two parts. Okay. So if your metal is at this potential and this pH, it is very sure to undergo corrosion. But if the potential of iron metal is maintained this or this, then it is rendered cathodic and the metal is protected. So that is the Porbix diagram. So Marcel Porbix correlates the possibility of corrosion, stability of metal with pH of solution and oxidation potential. It also gives corrosion product composition at different pH and potential. It shows the condition of immunity, corrosion, and passivation. This information can be used to control corrosion of pure metals in the aqueous environment. But this particular system is for iron, which is studied in very much in detail. Now, a more enlarged figure or better understanding is developed how you can passivate it. Iron can be passivated by rendering it anodic, but the potential range in which it remains passive is small. So this is the cathodic protection region, and this is the corrosion region where corrosion would be taking place. So this is the Porbix diagram. Okay. So what is passivity? So passivity is if a metal is corrosive in some environment, okay, you passivate it by increasing or decreasing the potential. You passivate it by changing the pH. So passivity is uh, loss of chemical reactivity. Actually, if some metal is active or reactive in nature, then due to passivation, it will lose its reactivity. The loss of chemical reactivity of certain metal and alloys under particular environmental condition is called as passivity. Okay, so this is a favorite question in corrosion chapter. So some metals can act as active as well as passive depending on environmental situation. Passivity occurs due to formation of stable film that is of around 3 nanometer thickness on the surface of metal. That is why it gets passivated. So metal oxide layer adheres to the parent metal, and all the metals like Fe, Ni, Si, chromium, titanium and their alloys show passivity effect. So effectiveness of corrosion reduction depends on the nature and properties of the protective film. Then passivation process. So you are passivating, this example we have already seen. By adding chromium to the iron, you are passivating this particular film or this particular metal because the film formed cuts the contact of oxygen with the metal, and thus we say that the metal has been passivated by adding chromium to it. Oxide film theory. Oxide or other compound film is formed on the surface. A film separates metal from the environment. A passive film of reaction product acts as diffusion barrier. So this is acting as a diffusion barrier. Adsorption theory. Passivity is achieved due to chemisorbed films of oxygen or other passivating agent. Films separate metal from water or other corroding environment. Film may be non monolayer or multilayer in thickness. Then passivity of iron alloys. How iron alloys are passivated. Just now I told you, iron with chromium of a percentage of more than 12, 11 or 12 improves the corrosion resistance due to formation of chromium rich passive film. Addition of more than 8% of nickel further increases corrosion resistance. Then there is 304 SS has about 18% chromium and 8% nickel. So along with chromium now you are adding nickel also to make it increase its corrosion resistance. Then further addition of 2% molybdenum to 304 SS increases corrosion resistance further. 316 is stainless steel has 18% chromium, 8% nickel and 2% molybdenum. See how step by step one and the other thing is getting added, and the quality of passivation is increased. Passivation of iron by HNO3. Now what we see, how an strong acid like nitric acid we can passivate iron. This sounds to be like absurd. But it is seen that Fe in concentrated HNO3, we find that there is no reaction due to formation of and metastable film of Fe3O4 on the surface of iron. So Fe3O4 metastable film is formed when a strong acid like HNO3 comes in contact with iron, and this metastable film is very much protective in nature and thus protects the iron. Whereas if the same nitric acid is a dilute one, then we don't get formation of a metastable Fe3O4, but this dilute nitric acid is not a strong oxidizing agent, and this does not give form metastable this on the surface, and therefore corrosion continues further. Okay. So this completes the theories of corrosion. Now we come to different types of corrosion. Now different types of corrosion are oxidation, uniform surface, pitting, intergranular, galvanic and stress corrosion. So one by one we will see what are these corrosions. So various forms of corrosion are stress corrosion, happens due to stress in the metal. Erosion, corrosion means the place, just now I told you, the place where friction will be more of the molten metal and the tube. Pitting corrosion happens due to a very small anodic area and a very large cathodic area. It starts, the pit starts forming due to small anodic area, and that is how pitting corrosion takes place. downward propagation of small pit and holes is seen. Then crevice corrosion. If you are having like the terrace on the terrace, if a metal um tank is kept like this, now this part becomes the crevice in which there is less of oxygen. So the metal from this part will come here and corrosion will take place in a crevice. Then galvanic corrosion is like formation of anodic and cathodic area due to difference in either the potential, the, the reduction potential of the metals or due to presence of uneven oxygen. Then intergranular corrosion. Now intergranular corrosion is due to formation of uh, the grains present in it during solidification undergo has a grain center. So this if this is the grain center, this part is becomes the grain boundary. So the place where there is an atomic mismatch, you get formation of grain boundary. Now why such a thing is there? Now you consider that the molten metal is cast into a sheet like this. Now, when it is cast into a sheet, nucleation starts just like this random manner nucleations will start. And the atoms of iron will arrange themselves around this very nicely. In the same way, it will start from here solidifying and it will go like this. Here it may start from here and it may go like so that is the intergranular corrosion says that it is the grain boundary which is eaten away by the either caustic soda or other corrosive environment. So that is intergranular. Selective leaching. So there can be selective leaching, preferred corrosion of one element constituent, and uniform attack theory. Or uniform attack theory will be a small cathode and a large anode. So uniformly they are undergoing corrosion. Okay, corrosion of iron, waterline corrosion. Yeah, waterline corrosion. I think I have told you this is O2 plus 4H plus 4 electrons giving you twice H2O and so on. So this is the cathode reaction and this is the anode reaction. Then coming to intergranular corrosion. Now in a 1 centimeter long piece, there can be thousands of such grain centers. This is termed as grain center. Every central part is termed as grain center. Okay, and the nucleation, the atoms start arranging like this around it, and the place where there is mismatch like this is termed as grain boundary. So grain boundary starts behaving like an anode and grain center starts behaving as cathode. Okay, C, not P. So a localized attack takes place and the grain boundary is eaten away and the whole grain is dislodged into the electrolyte or water present around it. So depletion of alloying elements at the grain boundary takes place and the grain boundary acts as anode and the grain center acts as cathode. Okay. So you can go for removing the internal stresses present in metal by annealing. So how annealing, low temperature annealing and high temperature annealing will change the properties of metal. Now it will remove the air entrapped, it will remove the stresses present and the whole atomic array which is arranged here like this till this part. It starts from center and it goes and stops it here. Okay. So many carbides do not fully dissolve. Limited amount of carbon to along the new grain boundary is seen, and to slow down grain growth, small grain uh, small grain size can be dislodged quickly. So a large grain size should be there. To remain as intergranular carbides, if they remain as intergranular carbides, welding part then more of corrosion takes place. Whereas carbides are dissolved easily here at high temperature, and therefore easy grain growth is there. The grain here, if it is like this much, after high temperature annealing, it grows to a larger size, and easy grain growth, low surface energy, carbides decorate new grain boundaries. Original grain boundary is shown here with the dotted line, and carbides fully dissolved through the solid line. Okay. So then the next part, that is intergranular corrosion. Now the pitting corrosion. Now pitting corrosion is seen here. The metal is large enough, but we see that the pit goes on forming, and the whole metal at one place only is eaten away, and rest of the part is not. Because of formation of pit, the metal becomes embrittled. Okay, formation of micropits, sharp holes, cavities result from or breakdown of protective coatings, scratch or small surface defects. For example, iron aluminum in chloride solution will undergo rapid pitting corrosion. So the mechanism of pitting is metal in oxygenated NaCl electrolyte will undergo very rapid pitting corrosion. Okay, so M plus is pitted by aerated NaCl solution. Rapid dissolution of metal create excessive positive charge in the pit, which attract chloride ions from the electrolyte in the pit. So pit content high concert pit contains high oxygen, high concentration of metal chlorides, chloride molecule, which react with water to produce HCl. Yes, HCl and metal hydroxide. So H plus accelerates the corrosion process. So pit acts as anode where O2 concentration is almost zero, and it is locus of rapid dissolution of metal. Uh, Cathodic oxygen reaction takes place in the metal surface outside the pit, and prevention can be done. Lessen the aggressiveness of the environment. Chloride ion should not be used or should not be there, and upgraded material of construction should be used which does not contain chloride. Okay. Then is the crevice corrosion. Now the crevice corrosion may take place at this particular crevice, or as I told you, if you are having a tank and it is kept over a surface on the terrace, then this becomes the crevice, and the part which is exposed to lesser concentration of oxygen becomes anode, and the rest of the part starts behaving cathode, and corrosion takes place. Then stress corrosion. Now, if I have a tube and I want to bend this tube at an angle of 90-degree like this, so you may heat it and bend it. Now, what happens here? What all grains were there? Now, grain concept you have understood. Now, the grain experiences greater stress due to you are bending it at this point. Then here it will be relaxation stress, here it will be compression stress. Okay, so stress corrosion results from combined effect of mechanical stress, bending tensile stress and corrosive environment. Steel bar introduces high stress at the bend, which then is anodic. Compression stress is not damaging, and you see that the if this is the stressed point, here you can see the corrosion has taken place, and because the grain boundaries move apart when you are, like, ductility and malleability is the property of metal, and because of this ductility and malleability you are able to use it, and you will find that the grain centers lead to such type of cracks in between, and along the cracks now corrosion will take place. The caustic embrittlement that we saw in the boiler troubles chapter is a type of stress as well as intergranular corrosion. So you can see due to stress the grains are moving apart, and due to moving apart of the grains, the grain boundary is exposed to corrosion to take place, and that is why it leads to corrosion at the stressed part. Okay. So caustic embrittlement focus at stress part of the boiler such as cracks, rivets, bends and joint. It is a form of stress corrosion in boiler. Boiler feed water usually contains some residual sodium carbonate. At high temperature and pressure, it undergoes hydrolysis, okay, and formation of brittle irregular cracks on the boiler shell due to the accumulation of caustic substance happens. If there is sodium carbonate in water, then we know sodium hydroxide will form. This sodium hydroxide attacks the iron metal, forming Na2 FeO2, and it will keep on producing NaOH repeatedly, and this will lead to corrosion of large amount of iron, and that is how the embrittlement or the boiler metal becomes um, thin and the danger of explosion is there. So it leads to a cell where Fe under stress is there, concentrated NaOH, then dilute NaOH and Fe, which is stress free. This leads to formation of cathodic and anodic areas. So under stress, iron forms anodic area, stress free iron forms cathodic area. Then uniform or general corrosion, like there is a uniformly distributed iron oxide in a seen, that is a uniform corrosion produced by moist direct chemical attack. A uniform layer of rust is formed on the entire exposed surface, and the atmospheric example is atmospheric exposure of metal, and maximum metal loss by the is in this form. Okay. Microbial corrosion. There are different type of bacteria which like sporo, vibrio, desulfuricans, then anaerobic bacteria, sulfate reducing. They will lead to formation of such FES at the surface, and this will lead to, like, first of all, oxidation of Fe2 plus. Then at the cathode you are having some you are having some electrolyte, and you get formation of hydroxide, which finally, like, 8 electrons are coming from here. These 8 electrons react with H plus, forming some with some sulfur, leading to water sulfate reducing bacteria or sulfate oxidizing bacteria. So you can see the diagram in which how the rust has formed. Rust will be having the greater volume than the metal used in oxide formation, and that is how it will then start blocking the thing. Then sweat corrosion. Sweat corrosion, water with dissolved carbon dioxide. So if water contains carbon dioxide, it leads to formation of FeCO3. Now, how the reaction takes place? Anode reaction is fixed. Fe goes into the solution as Fe2 plus with 2 electrons. These 2 electrons from the anode side moves to the cathode side, and at the cathode side, these 2 electrons are used up by the bicarbonate ion, forming carbonate ion, and this carbonate then reacts with Fe, forming FeCO3. Okay, so that is the sweet corrosion. So corrosion control, there are different types of methods by which you can control corrosion. One is design and material selection. Another one is using certain coatings, that is organic coatings like paints, varnishes, lacquer, enamels, anodized vitreous enamel coating, and so on. Then you choose a proper design, then you can definitely reduce corrosion. Then cathodic and anodic protection. So you render the structure anodic or cathodic and protect it, and environmental factors. Okay. So material and design selection we will see in the next class, that is on Monday. So how much is remaining? Okay, fuel cell and numericals. So fuel cell is okay. 10 minutes matter. So Monday we will complete the corrosion part. Okay,
And
so I'll put this here. Yes,
ma'am, will be lab to tomorrow. Lab.
lab. Now, how many experiments we have completed? Monday will be 7th of February, right?
24.
How many experiments you have completed? Have you completed 8 experiments? Hmm? Before sessional, 4 experiments. After sessional, 4 experiments. After sessional, now first four you have already submitted. Next is ion exchange capacity. The aim was determination of the ion exchange capacity of cation exchanger resin. The sixth experiment was verify Freundlich adsorption isotherm and study the adsorption of acetic acid on charcoal. The seventh experiment was mm, determination of cobalt spectrophotometrically and verify Beers-Lambert's law. And the eighth experiment is determination of gross calorific value of coal sample using oxygen bomb calorimeter. These 4 experiments you are supposed to write in your file and upload the file. That uploading, I'll put the deadline as assignment on by 26th. And 28th, you will have an MCQ test. Things are clear?
Yes, ma'am.
No, today is what date? Today is the 19th,
19th.
not 7th. Today is 19th. Okay, so today is 19th. So next week is you have to prepare, you have to submit your file, and I'll take an MCQ test so that your practical evaluation also gets over before number of things will get over before the 1st of March, and only Viva part, that is 10 marks Viva. For those students whose Viva was not taken, together 20 marks Viva will be conducted, and that part will be. So by 5th of March, I should be able to give you marks of your practicals, so that then we can concentrate on your theory part. So your theory also I want to finish within February only. Are you getting? Where is the CR? CR is present here. Shreya Dhote. And from the boys, who is the CR for X section?
Yes, ma'am.
Okay. Now you inform that most probably all the theory part, teaching part will be done in February only, and practical evaluation, practical teaching part or lectures are over. Now you have to just upload your 4 experiments, and so that will complete this part. Any doubt from your side? We can discuss on Monday again if
No,
you have
ma'am.
any doubt.
Ma'am,
Okay.
link for submission of assignment.
Yeah, that I will create and send you. Okay. And in the same classroom, you have to say put, but the assignment I'll create today or tomorrow. Tomorrow is Sunday. No? Sunday I'll do all those part. Okay. So no more doubt. We are left with a portion of interaction of radiation with matter, where Beers-Lambert's law is an important law, and that's why the practical was there. Then we are left with some part of coordination chemistry, which you have already studied. So, three name reactions I gave you, you have to write on your own. I have the PPTs, I'll just discuss it in the class. And the crop synthesis is there, that is crop quinoline synthesis. So that I will be discussing, because you might not get crop synthesis. So that reaction we will discuss here. And what else is remaining? Name reactions, organic, coordination, interaction of radiation with matter. These three topics are remaining. So Monday, Thursday, and Friday. By Friday, all the topics will be getting over by next Saturday, 26th. Clear?
Ma'am,
Okay. So, yes, I'll close the meeting now.
ma'am, in assignment there is 2 marks for each.
What?
In the second question, there are 2 marks for
In
each
the
one when assignment there is given.
No, I'm not getting what you are saying.
3
Please.
marks for
Ma'am, there is confusion regarding marking scheme in assignment.
अरे यार मार्किंग स्कीम इसलिए दिया है, इट हैज बीन गिवन कि आपका जो लेंथ ऑफ आंसर है, यू शुड नॉट कीप ऑन राइटिंग 20 पेजेस. The marks are given, you have to consider that if a question is asked for 2 marks or 3 marks, what should be the length of your answer. You have to put the important points, and it should be summed up in half a page or one like 3/4 of a page, and that should, it's just to restrict you from writing long answers and long sentences. That has been put, क्योंकि एग्जाम में अगर पूछा जाता है तो इट इज आस्क्ड फॉर लाइक राइट द प्रिपरेशन प्रॉपर्टीज एंड एप्लीकेशन ऑफ से टिफ्लॉन or PVC or Bakelite. So that way you should be able to write what are the monomers, that is the precursors, then what is the final structure of your bakelite, that is the synthesis, then preparation, then what are the properties, what is its softening temperature, that is the most important for polymers, and up to what temperature that can be used, और जब आप इंडस्ट्री में उसको अप्लाई करोगे तो up to what temperature it can be used. Then you are having application. So where all you are using, like Bakelite is used for your number of lids where high temperature is maintained. Then the handle of cooker, pressure cookers, and the pans and all are made up of Bakelite, because when you are heating it on the LPG stove, it will get heated up. So Bakelite will not. The secondary bonds will not. It is all the three-dimensional network of covalent bonds, so it will not fuse and become plastic. Okay, it will remain solid. At very high temperature, it will directly decompose and form char, and like CO2 will be liberated. Okay, so these are the like that is why it is given, and it is a very theoretical portion. That's why some topic has been given. If you want any material, I can give you book PDF from which you can write. Like for example, conducting polymers. Conducting polymers का एक 3 to 4 page book PDF is there. If you want, I can put it on your group. So from that, then you can take N type and P type, P doped, N doped conducting polymers, and so on. Polypyrrole, polyaniline, and all those things.
You share that, ma'am.
Conducting polymers, right? Conducting polymers PDF I'll put in the WhatsApp group. For name reactions, I don't think there is any issue. You have to write first the general reaction, then you write general reaction will be a single step reaction, but then you give the mechanism how the protonation or deprotonation or formation of carbocation or carbanion ion, and these things are taking place. The presence of chloroform will influence what formation, whether aldehyde will form or acid will form, all these things. Things are clear?
ma'am.
Yes.
There is 2 marks each.
Assignment पे 10 marks है, 10 marks are there on assignment. If you write all the answers and submit within time, you will get 10 marks for assignment.
Ma'am, where we have to submit theory assignment?
That also tomorrow is Sunday. I will put an assignment in your classroom. So in that assignment you can submit. So I'll put an assignment in the theory class as for the theory assignment, and for your file submission in the respective batches, classroom batches, I'll put assignment for submission of your chemistry files. Clear? Tomorrow I'll be
Okay,
doing
ma'am.
all those things. Okay? Okay. Still, yes, please write down your doubts in your notebook and just ask whenever we are having theory class. Okay, because once the theory explanation gets over, then we will not be conducting any class, then only WhatsApp group will remain the way of communication. Clear? Okay, so we close here today.